Okay, so this is a program called Cura. There's a variety of different programs out there. I use multiple programs depending on my model or depending on the printer that I'm using, because some have different features or capabilities. But what you can do is you go and select, make sure that you have the right printer, because as you can see, here is my Ender 3 Pro, but then here's my Creality, and you can see that there's a size difference. So you want to make sure you've got the right one selected. Now, over here, you've got basically your profiles and everything that goes through with it. Now, super fine quality, 0.12, that will take the longest amount of time to print, because what it does is it prints the most amount of layers at the finest amount. So if we were to do something and I was to say 0.028, I'm just going to do a quick sketch here. So imagine the thickest one, which is the fastest, is because it is laying down a thicker bead of plastic and layering it each time. Wherein if I go for the super fine quality, 0.125, each bead is exactly that, 0.12 millimeters. So the gaps are smaller. And you can kind of see here as a comparison wherein it does more layers. It allows it to give it a smoother finish, as well as better details. Now, what you can do is go through and then adjust things. So you always want to be very careful and know what are you using the smoothness for, to what level and what resolution, because you can do a 48-hour print, or you can do it with a few setting changes. That 48-hour print can become a 3-hour print. So what is it that you need? Do you need a super fine surface, or can you get away with something a little bit rougher? You know, or can you get away with something that's a little bit rougher and you just skim it with Bondo? You know, is it a, hey, I need to hold it in my hand and it doesn't have to be smooth, I just need to get the overall feel. So you want to be very careful on what you get with that. So what we'll do now is we'll bring these in. Now these should be, I think the beds are 250 millimeters by 250 millimeters by 300 millimeters, I think. But with that said, you need to understand what your model is. Now, what we're going to do is export this out. And what you want to do, you need to export it out as a STL file. So we're going to come here and we're going to go File, Save As, and we're going to go to STL. What that does is it turns it into a mesh. And that's what the surfacing that's what Ultimaker needs, is a surface or a mesh file. So we're just going to go in here. I'm going to go to Options. I want to make sure that when I export it, it's smooth. If I bring it in like this, a circle will be faceted when I print it, which is great if you just want to go quick, but we want a circle to be a circle. So we are going to go with a nice fine one. Now, in this model, we have multiple bodies. So I can come in and go, oh, where is it? I want to go and say, I can either save all my components in a single file, and I'll show you what happens. So I'll do this, and we'll save it as a single file. There it tells me we've got it. Now, what I'll also do, I'll go back to the STL. I'm going to go to my options, but this time I am going to, where did it go? I'm not going to save it as a single component. What that does, you can already see here where it saved it all as one giant object. What this is going to do is it's going to take each individual component and save that out. Shoot. There. Now if I come back here, go to my downloads, you'll see it saved out each individual piece. So that we've got that now. So what we can now do is come into Cura, and we can go and just say open. We'll go to where these are. Now, so this is where it brought it in as one giant object. And the problem is what you're seeing here is that it has these striped lines because it's telling you that it doesn't fit onto the print bed. Now, that's not necessarily a bad thing. But you can see here, it doesn't fit. Let's go to a side view. Plenty of room here. So what we want to do is take it and we just select it. Over on the left hand side we have a lot of different options. You can move it around and you can type in the numbers by moving it, or you can drag it around like this, or we can come in and rotate it. Now for this, we're going to go snap rotation, and I can reset it, I can grab these and rotate it, or I can also say, hey, lay it flat on that face. So if we come in here and we go 90 degrees, not quite sure. There we go. So you can see by moving it around and positioning it, I got it in the right spot so that it fits all within the bed. And I know that because it's yellow. Now, here is something to keep in mind when you're doing this and you're positioning things. You need to have what's called support structure. And what that is you can't 3D print something and just have it hanging in space like that. There's nothing for it to print on. So you need to tell it, hey, let's have support structure. So that's where if we come down and we go to support structure, we want to make sure that we have it turned on. Oops, 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 oops. And you see here where I'm having it set is at 50 degrees. So anything that is greater than 50 degrees, I'm saying build support for it. So 90 degrees, obviously. If I was to do 50 degrees, and the reason for that is because it's actually able to do it without support for 50 degrees. If I come back and I go slice, what slicing does is it runs through and it's creating what's called the G code, which is the file that the 3D printer needs to read. So what this is now doing is it's going through and taking a look at everything to show what we've got. Now, let's look at this right now. We've got 9 hours, 9 days, 11 hours for this. Let's go to preview. There is this much support structure. There's more support structure here than the actual model. So it takes that much time. Now, we can also come back and say, well, let's just do a standard quality. That's not a bad quality to go with 0.2. Even 0.28 would be good, but just by doing that, we had 9 days. Let's go with a slice. We went the wrong way. It went to 10 days. Well, that's just bizarre. Hold on, let's try it again. Okay, so now we're down to 7 days. And a large portion of that is still all this extra material in here. So this is where we look at it and we say, okay, what are the different ways to do it? Because even if this was a reasonable time, let's say 2 days, the chances that maybe halfway through something gets ruined is high. The longer that thing is running, the higher probability that something could go wrong. So you want to be careful. So that's where you want to look at your model and say, okay, well, in this example, what can we do? What if, how high it is and how much it's printing? What if we were to come and we're just going to come in here, I'm going to right click. Shoot, I'm not in. I wanted to be in. Okay, hold on. Fusion 360 is really nice because you can just right click on a body and say export. No, it's not going to let me do that. I want to export just that. Okay, give me a second here. Okay, give me a second here while I think, because it's been a while since I've done this. Okay, so I'm gonna cheat here. I want to get these all as individual components. So I'm going to just right click. I'm going to insert into new part. I'll give it a name. Come on. Okay, bear with me. All right, tell you what. I'm going to pause the recording. Why don't you guys take a 15-minute break, and I'll get these parts all saved out so that when we come back, we can do it. Okay? Okay. So what I did is through SolidWorks, I went and let me just open it up. I went into the model, and for each one of these objects, I highlighted it, I right-clicked it, and I said insert into new part. What that did is it automatically inserted it in a new part. I was able to save it, and then what I'm not sharing my screen. Let me share my screen. So let's go back again. We'll step back here a little bit. So because they're all solid bodies, I could come here, select it, right click, go insert into new part. What it does is it automatically opens up a new SolidWorks model window, puts it in here, and now we've got a new part. You can see here it says it's stock. What this allows me now to do is I can go in and I can save out just this one piece as an STL versus where I was struggling before with the workflow of trying to save out individual components within there. Now, the one thing though is if I come back to this model, and this is where when we start building assemblies, I'll show you a little bit more about it. But if I come in here and I edit this part, if I go to that part now, it updates. So there's a link. Normally what I would then do is I would drag these all into its own assembly, but we're not going to worry about that for now. So what I then did is, and I'm going to just delete all of these because I want to show you first. What I then did is come in, and I've named them all STLs, just like I did before, and I can just drag and drop them all at once, and they'll go wherever they need to go. You can see These ones obviously can't be printed because they're off the bed. So I'm just going to drag and move them around until I get them to be highlighted yellow. And then same as this, we'll move this one to wherever it needs to be. So right now we've got everything laid in. That one's vertical for whatever reason. We could rotate that too. Now, here's something for some of your models when you're doing it. The most precise way for it to create a circle is from a top-down view, because it's going to draw that circle and it can go in that rotation, versus doing a circle in this orientation. And the reason for that is it has to go and do little steps to get that circle. So a very, very high end, so a top view, the circle looks like that. From a orientation like this, and I'm just going to kind of, give me a second while I sketch that out. It does a step thing because the 3D printer goes pass, and then does another pass. So it's not as tight of a tolerance, not as smooth either. I don't think it's going to be an issue for this. But you can see here, let's just look at this orientation. We've still got the exact same amount of mass. We can now rotate things so that they don't use or don't need as much support structure. I still have them slightly raised off the bed. I like to do that because it makes it further cleaner on the edge. But if I come in now and I go slice, and I haven't really changed anything, it's still low quality, whatever, initial layer height, we're down to 12 hours now. So you can see by removing all that extra filament, we saved a lot of time. Now, I can even go more so if I sit there and say, okay, these are all set to my presettings. Infill. If I come in and I go preview, infill is how much of that internal structure. So this here is a solid bar. And you can see it's put infill in there so that, you know, it's not a pure solid bar. It's only 45% fill. If I came back and said I want that to be 100% for everything, and that's the thing. I can't pick one piece and only have it at 50% infill. It's everything on that bed. But here you can see now it's much more solid. But you've added 3 hours to it. So there's give and take. This is a much stronger piece. It's not going to be delicate or as delicate. You can come back and say, you know what? I would be fine with a 30% infill because I'm going to be there to micromanage it and make sure no one touches it. We'll get it down to 11 hours. Now, we could also at this point, let's say you wanted this circle to be cleaner and nicer. So that means we need to change the orientation. Well, we can now do that, because before you could only change the orientation one way. But now we can rotate it the opposite way, so we no longer have all that support structure that's needed. So, and by changing it, so we still added some support structure here, in this area here, but we're still at 11 hours. And this is going to be much rounder, cleaner, smoother. And you could do that for all of them. Now, one of the biggest things, how many of you have 3D printed something and have had a nightmare of a time getting your support structures off? Okay. So under support structure, there is support line distance. What that basically is what is the distance from the actual printed part to the support structure. If that is at, let's say, whoops, 0.1, no, that's not what I want. There. It's literally going to be attached to it, and it's going to be very rigid, very hard to get off. You're going to have to crank on it, dig and pull away. So what I would recommend is that you all make sure, whoops, 0.8, that number, I don't remember what this number was. What did I have this at? We're just going to have them both at 0.8. That those be at 0.08. That's what I find. Now that's on my machines, but that's what I find gives me the right distance to get the right amount of support, but I can still literally just grab an edge and the whole stuff just comes off at once. So make sure you pay attention. I don't know what your default settings are on there, but that's one of the ones that you want to check and make sure of. Yes, Carmen.
Did you say 0.8 or 0.08?
08, 0.08.
Okay, thank you.
Yep. So here is, I mean, it's a matter of just playing with all of these and getting them set up the way you want, finding that balance. So like here, we're going to get, again, and it's that trade-off. Here, we're going to get a nicer print for some of it, but now we're adding back in additional support structure. So if we come back, and this is still the low quality, what everybody, I don't know if anybody's ever done it, but there's the little frogs or there's the little boats or little models that you can print out. And what I keep trying to tell the students is buy those 3D labs, print the same thing out 5 times or 4 times. Super fine quality, dynamic quality, standard quality, low quality. If you want to do the tugboats, awesome. And sit there and put down how long it took for each one. Because then you can look at it and say, well, do I need it? Does it need to be, and we'll see who the geeks are, does it need to be super fine detail like that? Or can I get away with, let me see if I've got something floating around. Or can I get away with something that is rougher and not as perfect. What do I need? Because that's going to make a big difference. I used to see students sitting there printing a part, and it was going to take, it took them 12 hours, and actually what it took them was 24 because the first one didn't work. And I was like, well, do you need this to be a super fine finish? Are you painting it? He's like, no, I just need something to hold in my hand. I'm like, well, then drop it down. And we got from a 12-hour print down to a 2.5-hour print. You know, so we really want to pay attention to that. Now, something else. If you're printing things and you're going to make a 3D model, sometimes you have to modify your model for the 3D print, i.e. maybe an extra structure or an extra support, or hold on one second. What McKenna did is she wanted to be able to have this post spin. So everything else gets glued together. And you can see, we went from printing this as a ridiculous 10-day print to 10 hours and then maybe 3 or 4 hours of putting it together. So she also went in and modified her model. Let me just do a cross section. So that I don't think you ever needed this long of a post. You could probably save time printing this, McKenna. You probably only need that down to about here. Just so you know. But now, this will drop in and she'll be able to pivot and rotate it. What she also did was she left a gap here because there's tolerances. If she had extruded this all the way down to the bottom there, these don't print 1-to-1. There's different tolerances. So it might not have fit properly. She also left some clearance holes or gap clearance here because it has to go in and spin. Now this gap might be a little too much, McKenna, because there might be a little bit of wobble in it, but that can also be fixed very easily by, you know, and then this is prototyping. If it goes in and it's a little sloppy, well, you don't reprint it. You grab a napkin or something thin and you put it in there to wrap around it. You also might want to put a little bit of grease in there because plastic on plastic won't give you that nice smooth rotation. So this, by tightening that up, it's no longer just flopping, and a little bit of grease, if they go up to it, you know, it's nice, versus you go to spin it and it kind of goes clunk, clunk, clunk. You want that, ooh, that's nice. Questions? Is this useful?
Yes.
Okay.
Okay. And also, if anybody needs help setting like a printer up in person, I can help you.
There we go. Awesome. That's worth beer. I'm not going to get into the rest of the stuff. Use it as a default. Don't start messing with your speed. Just use everything else as a default. And what you want to do too is, you know, what Carmen will help you with is that first initial setup. That first, getting those first few layers on there are what's very, very important. If your filament isn't sticking, you can use a glue stick to make that